Math 102, example 3.5.5. So we've seen vertical asymptotes. Our other types of asymptotes are horizontal and oblique asymptotes. These will require some memorization. As you can see, we have 4 cases, and to determine which case we're in, we're going to look at the degree of the numerator and then the degree of the denominator. So our first case, this is where the numerator and the denominator have the same degree. So it doesn't actually matter what that degree is, just that it's the same. I've got HA as shorthand here for horizontal asymptote, and it will be the fraction, which is y equals the leading coefficients, which have been then reduced. So let's skip down to my example and look at A there. So here I have 3x plus 2 over 2x minus 7. So the degree of that numerator is 1. Remember, if there is no exponent, we understand it to be 1. And the denominator is also degree 1. So this is the first case. Now I number them just to keep track. You don't need to know the numbers of the cases. So my horizontal asymptote is going to be the fraction y equals those leading coefficients, 3 over 2. This case we can't reduce it, so that is going to be our answer. Now, I always mention the oblique asymptote as well, because on a test I might ask you, what's the horizontal asymptote? In which case my answer is y equals 3/2. But I might ask you, what is the oblique asymptote? So if I ask you that, my answer would be, I don't have one. Now, on the calculator, again, it will not tell me this directly. So let's start by graphing that function. Again, notice I have parentheses around the numerator and parentheses around the denominator. So if you look, we might be able to tell that it's approximately 3 over 2, but it's a little bit hard to see that graphically. So I'm going to come back to y equals, and I'm going to graph that horizontal asymptote as a second line. So now let's see what it looks like. So an asymptote, what that means graphically is the two lines get closer, 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 closer without touching and without crossing. So if we look at that second line, the y equals 3/2, that hopefully looks like my function is getting closer and closer and closer to that without touching it or crossing it. All right, let's hop back here for my second case. So here the denominator has the higher degree. So let's look down at part B here. So that numerator is degree 1. The denominator is degree 2. So the denominator has the higher degree. We are in case 2. There is no computation here. This is straight up memorization. My horizontal asymptote is the x-axis, is y equals 0. And once again, just in case I ask you this on a test, there is no oblique asymptote there. Let's shift this down a little bit just so we can see. Our third case, this is probably the hardest case. So here, the numerator is exactly 1 degree higher than the denominator. So if I look at part C here, the numerator is degree 2, the denominator is degree 1. And that is generally what we will have for this third case, because we will have an oblique asymptote, and we're going to find it by doing synthetic division. So in the half box, I put a positive 2. Since there's an x in front of the number, that means I change the sign. And to the right, I put the coefficients of the dividend. I have a 0 here because there is no x term. So if I do synthetic, I get all of this. Now, we will generally get a remainder, but we are going to ignore that remainder and look at just the quotient. So here my oblique asymptote is y equals 1x plus 2. And again, just in case I ask this, let's be clear that there is no horizontal asymptote on this case. Let's go ahead and graph this one as well. So you'll notice I've graphed the original function as my y1 graph, and much like I did on the first one, let's graph that asymptote as y2. So if we graph that, here's my actual function. And as you can see, there's the oblique asymptote. Oh, we also sometimes call them slant asymptotes because they are they have a slope, they have an angle. And once again, it won't tell me that directly, but if I graph both of them, I can look at the graph and see that I'm getting closer, 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 which is what an asymptote should look like. Let's just scroll down so we can see our fourth and final case. We do not see this case very often, but every now and then it does show up. So here, my numerator is 2 or more degrees higher than the denominator. So here, with a cubic on the top and a linear on the bottom, this is that fourth case. And the good side about this is it's pretty straightforward. We do not have a horizontal asymptote. We do not have an oblique asymptote. We would still have a vertical, but we are not interested in that right now. And again, those are the cases. So again, you will need to have these memorized. The calculator can help you check the answer, but again, you do need to have them memorized.